This paper was of great interest to me, having worked in League Two and being familiar with the gruelling schedule and subsequent physical demands on players. In football research, the frequency of high-intensity match actions, such as accelerations and decelerations, have been widely researched, and having the ability to perform them effectively and efficiently may be a crucial physical component of overall match performance. Whilst professional football not only requires high levels of physical, mental, technical and tactical attributes from its players, it also requires players to carry out unpredictable but frequent intermittent bouts of high-intensity actions such as jumps, tackles, sprinting, and of course accelerations and decelerations. These frequent high-intensity acceleration and deceleration actions form part of a team's playing style or philosophy, such as the pressing style seen in Jurgen Klopp's famous heavy metal football. The ability to sustain these actions across a 90-minute game, or perhaps longer, allows players to adapt to any tactical or technical demands, close opponents, win duels, create space with purposeful movement, or defend potential goal opportunities, all of which could be said to be crucial to successful team performance. However, the influence of these high-intensity acceleration and deceleration actions on match outcome has not previously been observed within football science research. While there has been a large focus on total distance and high-intensity running, these are often reported in isolation, which, as previous research demonstrates, may fail to accurately measure player internal and external load, and therefore have the potential to underestimate the physical stresses imposed on players during match play and training. Subsequently, the volume and frequency of high-intensity accelerations and decelerations within a game may expose players to significant mechanical and physiological stress, therefore potentially increasing recovery timelines and decreasing future match performance. In Norwegian football, it was suggested that accelerations and decelerations contribute to between 5 and 10% of total player load. However, the contribution of these metrics in elite English football isn't particularly clear within the current literature. For this research paper, the authors observed 26 players from League Two during the 2019-20 season. Their subjects included 5 centre forwards, 4 centre backs, 7 central midfielders, 5 fullbacks and 5 wingers. Throughout the season, the team were consistent with a 4-3-3 formation across a 57-game season. However, in 12 games, the formation was changed and the data was subsequently excluded from this study. The games were categorised as win, draw or loss. Also categorised was the period in which games occurred: a Saturday game in isolation, a midweek game, typically Tuesday in League Two, and a Saturday game that followed a midweek game. The frequency of accelerations and decelerations greater than or less than 3 meters per second squared, respectively, were analysed for this study. The total team frequency and effect size differences between the high-intensity acceleration and deceleration during matches with either a win, a draw or a loss were reported as per the graph on this video. Interestingly, and regardless of match performance outcome, there was a very large difference between the frequencies of decelerations compared to accelerations, with the largest difference observed in games lost. Furthermore, the highest team frequency of accelerations and decelerations was observed in games won compared to games drawn or lost. In this paper, the authors also observed that fullbacks and forwards had higher acceleration and deceleration outputs compared to the centre-backs, centre midfielders and wingers, which may reflect the style of a 4-3-3 formation. However, this may be hard to speculate, as this is actually the only study, the only formation looked at in this study was a 4-3-3 and has not been compared to any other formations or styles of play. That's not to say that the match outcome doesn't influence physical performance metrics, but there are differences in positional outputs, which is supported in this research paper. The main findings of this study suggested that there were large differences in between the frequency of high intensity accelerations and decelerations, regardless of match performance outcome, either win, lose or draw. Supporting previous research, the authors of this study demonstrate that high intensity decelerations were performed a lot more frequently than accelerations, regardless of the match outcome. This also supports the notion that from a physiological perspective, there is a greater use of eccentric muscle action when frequently decelerating and changing direction quickly in games. One salient point that was made by the authors is that accelerations within match play may be from either a rolling or standing start, and this therefore may subsequently influence the rate and volume of high intensity accelerations during a game. As suggested by the authors, players should be exposed to high intensity decelerations, and the monitoring of these should form part of player load management across training cycles. This gives some scope, in my opinion, to exposing players to small space constrained sessions with frequent high intensity decelerations and changes of direction. However, I do agree this needs to be monitored carefully in the best interests of the players and their physical preparation. The authors also give sound rationale as to why a high amount of high intensity accelerations and decelerations were observed when the team won, as opposed to losing or drawing games. Their findings support the chaotic nature of the game and the higher demand to perform high intensity actions both in and out of possession over a 90-minute game in order to influence the match performance outcome. While the highest difference between the acceleration and deceleration frequency was during games that were lost, the authors attribute this more likely to be due to the defensive agility actions such as pressing or reactive braking movements to close down an opponent. Also in this paper, there was a moderate effect for the game type. A Saturday game followed by a midweek game, normally Tuesday in League 2, demonstrated significantly lower accelerations than the preceding midweek game. From a fatigue management and physical preparation perspective, this is interesting for practitioners. As noted by the authors, the team only won 1 in 6 games when a Saturday game was after a midweek game. While fixture congestion has demonstrated little effect on some physical metrics such as total distance, the findings of this research may give scope for the close attention to high intensity acceleration and decelerations performed by players within short timeframes that are common in football. This reduction in high intensity actions could possibly be attributed to accumulative fatigue or the player's insufficient recovery from both training and games in quick succession. This could also be important for team selection, such as rotating the players within these fixture congested periods. This paper is the first known research to investigate the influence of high intensity accelerations and decelerations on match performance within a League 2 football team. From this research, there is certainly scope for practitioners to consider the monitoring of high intensity actions within training and match play from a fatigue management perspective, especially during those periods of fixture congestion as touched on earlier. Overall, while this research is novel, the findings suggest there may be an impact from these high intensity actions on match performance outcomes, and therefore this places an emphasis on the importance of the positional demands for players and the subsequent physical preparation.